Good day, students. I hope you are doing great. Okay. Today, our main strand is fraction. Our substrand that we're going to talk about is how to find the LCD, which is the lowest common denominator, or the LCM, which is the least or lowest common multiples. They are all the same, okay? The LCD and the LCM are the same. So how to find the LCD or LCM of denominators or fractions? And after then, we talk about how to change improper fractions to mixed fractions and then change it back to improper fraction. That is the vice versa. Our discussing can be traced through the new curriculum BX6 strand 1, substrand 3, content standard 1, and then the indicator that we are basing on is 2 here. When you look through the BX6 curriculum, we are using the indicator 2 of the strand 1, substrand 3, content standard 1, and then the indicator 2 with its exemplar. BS5 can also be traced in BS5 curriculum, strand 1, substrand 3, content standard 1, and indicator 3 here with exemplar. So these are some of the resource packs that we are using based on to find the LCD and the LCM of the denominators and how to change improper fraction to mixed fractions and then change it back to improper fraction. We have some terminologies in fractions or terms that you'll be using will be familiar when you are dealing with the additions and subtractions of fractions, especially when you are comparing two, you need to also know these terms. Once you are dealing with how to compare fractions, how to add fractions, and how to subtract fractions, these are some of the things that you need to make note of that. First thing that you have to do is that you change all unlike fractions to like fractions whenever you are solving for addition and subtraction of fractions. And in addition to, you can also do this when you are comparing fractions to, you have to change all unlike fractions to like fractions. Good. When you talk about unlike fractions, they are fractions with different denominators. Example, 2/5, 1/7, 4/9. These are the fractions. You could see clearly that the denominators here are 5, 7, and 9. The denominators are quite different here. So as a result of this, we call these fractions unlike fractions. When you talk about like fractions, they are fractions with the same denominator, which means that they are in the group, okay? These fractions are like fractions, which means they have the same denominator. Here, the denominators are 7, 7. So example is 1/7, 4/7, 6/7, 5/7. So obviously 7, 7, 7 here are the denominators here. So fraction denominator in they are like fractions. Again, you can also come across with this term here, mixed fractions. When you talk about a mixed fraction, they are fraction with a whole number. So which means we have two things here, the whole number and a fraction. When we have a whole number and a fraction put together, we call it mixed fraction. Mixed fraction is a fraction with a whole number and then a fraction, okay? A fraction with a whole number, which means the whole number is attached to a fraction. Example is that 8 whole number 1/7 is a mixed fraction. Another one is 4 whole number 3/5. Another one is 1 whole number 1/2. So the whole number has been mixed with a fraction. So we call it mixed fraction. Mixed fraction can also be called improper fraction because they are likely to change to what? Improper fraction. So let's see this term here, the improper fraction. Improper fractions are fractions in which the numerator is bigger than the denominator here. The numerator is bigger than the denominator. So these fractions are not normal, okay? The numerator is always bigger than the denominator. So we have the 7 out of 3, 5 out of 2, 8 out of 7. So the numerators are always bigger than the denominators. So these are also examples of improper fractions. When you talk about the proper fractions, the normal fractions, okay, the proper fractions are always less than 1. While improper fractions are always greater than 1. Okay, so that is another difference that you can also make from proper fractions, fractions in which the numerator is smaller than the denominator. So you have the 2 out of 5, 1 out of 7, 4 out of 9. So all these are also called proper fraction. They are less than 1. That's the original fraction that you are talking about. The improper ones are always greater than 1. Good. So these are the terminology that you must also know and understand too. So today what we are going to do is to how to find the LCD or the LCM of denominators of fractions and how to change improper fractions to mixed fractions and vice versa. How to find the LCD or the LCM of the denominators. The first thing you have to do is that you list the multiples of the denominators, or you list the multiples of the numbers that you wanted to find the LCD or the LCM. After listing the multiples, so the maximum, multiples has no end. So you can list the first 10 multiples or the first 11 or the first 12. That one to be okay. You list the first 10 or the first 12 multiples of each of the numbers given or of each of the denominators that you wanted to change. After the multiples have been listed, then you list the common multiples, which are the numbers that appears in both multiples of the denominators you listed. So when you talk about the common multiples, they are the numbers that appears in the multiples that you have listed, the first multiples, and at the same time appears in the second multiples. If there are 3, the number that appears in the first multiples, the second multiples, the third multiples. So the common multiples must be the number that appears in the multiple that you have already listed at the same time. Okay, good. Number a bar first multiple and the second multiple. So, let's say the third one at the same time. Those numbers are called common multiples, okay? Then after you have done with the CM, you know the LCM, the M there means you list the multiples of the numbers. The CM means what? The common multiples, the number that appears in both multiples. And then the last one is the L, which is the least. So you select the lowest number in the common multiples, the lowest number in the common multiple that you have listed. So that one becomes the LCD or the LCM. Good. You solve another example to illustrate that. How to change the improper fraction to mixed fractions and vice versa. To change improper fraction to mixed fractions. First thing you have to do is that you divide the number, which number that we are talking about here. You divide the numerator by the denominator to choose your whole number. So immediately you divide the numerator by the denominator, the first answer that you get is the whole number. After the division, the remainder is used as the what? As the numerator, but the denominator of the mixed fractions is the same as the denominator of the improper fractions. Okay, so the first thing is that you divide the numerator by the what? By the denominator to choose the whole number or to choose your whole number here. After the division, the remainder is used as numerator, but the denominator of the mixed fraction is the same denominator of the improper fractions. Good. To change mixed fraction to improper fractions. To change mixed fraction to improper fraction, that is the vice versa. Multiply the numerator and the whole number of mixed fractions and then add the results to the numerator of the mixed fraction to get the total numerator of the improper fraction. But the denominator for the improper fraction is the same as the denominator of mixed fraction. Okay, good. Let's try more examples. Let's find the LCD or the LCM of the following numbers. So the LCD of 8, let's assume that the 8 and 10 are denominators here. You want to find the LCM of that. The 8 and 10, that's the A. Let me write the solution for all. Good. So the A is 8 and 10. You are going to choose common denominator or the least common multiples of 8 and 10. First, we are going to use the multiples method, whereby you list the multiples of the 8 and then you list the multiples of the 10. After then, you select the number that appears in the multiples of 8 and at the same time appears in the multiples of 10. And that one we call it common multiples. After the common multiples, you select the least or lowest number in the common multiples. And that one becomes the LCM or the LCD. So let's use the multiples method. So the A. So the LCM of the LCD of 8 and 10. Good. So the first thing you have to do is that you list the multiple, which is the M. You list the multiples of 8. So here the multiples of 8. Starting with the 8. Then 8 plus 8, that will be 16 plus 8, that will be 24 plus 8, that will be 32 plus 8, that will be 40 plus 8, 48 plus 8, 56 plus 8, 64 plus 8, 72 plus 8, 80 plus 8, 88. Then I have listed the first 11 multiples of 8, and then you put 3 dots indicating that the multiples of 8 has no end. Okay, good. So once you have done, then you list the multiples of 10. Okay, you have the 10 plus 10 will be 20 plus 10, 30 plus 10, 40 plus 10, 50 plus 10, 60 plus 10, 70 plus 10, 80 plus 10, 90 plus 10, 100 plus 10, 110. Okay, then you put 3 dots indicating the multiples has no end. Okay, and then right there. Then you come to the CM. CM, which is the same as the number that appears in the multiples of 8 and at the same time in the multiples of what? 10. So you have the 40, which appear, the first common multiple is 40, followed by 80. Then you put 3 dots indicating that when you continue, you still get common multiples. And then you choose the least in the common multiples or the lowest in the common multiples. And that one is obviously 40. Good. So therefore, the LCM here is what? Is 40. The LCM for the 80 and 10 is 40. Okay, good. Then we can also use the other method to find the LCM of 8 and 10. Okay, that one I said we call it the prime factorization here, which is the prime here. Factorization method. Okay, good. So that one to be solved on this side. Good. Now you list the numbers, which is the 8 and the 10. Okay. Draw your nice table here. Then you choose a number that can cancel the 8 and 10 at the same time. So with the 8 and 10, they are all even numbers. So I will advise you, if the numbers are even numbers, then you choose what? The 2 to cancel. So 2 here can cancel 8 4 times here. The same 2 can also cancel 10 5 times. Okay, good. Now 8, it has reduced to 4. 10, it has also reduced to 5. We need to cancel until we get 1. That is the main motive for using this method. You have to reduce all the numbers to get 1. Now, we have gotten 4 and 5. The 4 and 5, which means the 1 is even number and 1 is odd number. When you reach the stage like this, I don't think you can get any common number to cancel the 2 numbers simultaneously. So the only thing you have to do is that you take the numbers themselves, okay, to cancel themselves to get 1, 1, and then you move, okay? So the first one is 4. 4 goes into 4 here. That one, 2 is 1. That one, 2 is 1. And therefore cannot cancel 5. So we have to repeat the 5, okay? Good. Now, the next number that you have to think about is the 5 to reduce itself to get 1. So we have the 5 here. 5 goes into 5. When you cancel, you get 1, okay? Good. Now, therefore, the LCM here CM or the LCD is the multiples of the numbers that help you to reduce these 2 numbers to what? To 1. So we have the 2 times 4 times 5, okay? And then 2 times 4 is 8. 8 times 5 is what? 40. Okay, we have gotten our 40. So the 40, when you use the multiples method, you get 40. When you use the prime factorization method, you also get 40. Good. Let's solve the other one here. The multiples of the 6 . let's solve the C. Okay, the 6 and 3, you list the multiples of 6 and then the multiples of 3, and then you list the common multiples within them, and then you list. So, okay, the B here, the LCD or the LCM of 6 and 3 here. Good. Then you list the multiples of 6 first. I have the 6 to 6, 1 plus 6, 12 plus 6, 18 plus 6, 24 plus 6, 30 plus 6, 36. Then you have to list the first 11 multiples of that. Then here you list some of the multiples of 3, because I know definitely I will get common multiples more than necessary here. So there's no need for me to continue. So the multiples of 3, you have the 3, you have the 6, 9, 12, 15, 18, 21, 24, 27, and then you stop. Okay. You can also get 30. Then you stop here. Okay. The 3 dots showing that the multiples has no end. Okay. Then you list the common multiples to the CM. So the number that appears in the multiples of 6 and at the same time in the multiples of 3, you have the 6, you have 12, you have 18, you have 24, I think. What I have, these are the common multiples. And then we list the least common multiples here, which is the LCM. So within the common multiples, the lowest number in is 6. Okay. And that is how to find the LCM of 6 and 3 after listing the multiples of 6 and then the multiples of 3. Then you list the number that appears in the multiples of 6 and the multiples of 3 at the same time. And then you list that one, you call it common multiples. Within the common multiples, we list the multiples of what? We list the least one in the common multiples, and that is 6. Okay, good. You can also use the prime factorization method to solve this one, whereby you have your the 6, you have your 6 here, and then the 3 here. Okay, you list them. So with a 6 and 3, you choose a number that can cancel or divide the 6 and 3 at the same time. Think the 3 can do that. So 3 cancel 6. It seems 2 times. 3 cancel 3. 1 time here. Then, so you have done with this one. Once you reduce the number to 1, it means you will not come back again. So the next number to reduce is 2 here. So the 2 alone, the number that we can use to reduce the 2 alone is the 2 itself, so that we can get 1. Okay, good. So we have the 2 here. So the 2 cancel 2. You get 1. Okay, good. And now we have achieved that one. Therefore, the LCM is the multiples of the number that we used to reduce the numbers here, which is 3 times 2. And that one is what? Is 6. Okay. So you still get the same thing, the 6. So let's solve the one involve the 3 numbers, and then if there's a space here, we solve the C first. So we are going to solve the multiples of, find the LCM of 12, 4, and 6. Good. Now the D. The LCD of the LCM of 12, 4, and then 6. Good. Great. Now you list the multiples of 12 first. Okay. To the 12. Now the 12. You have 24. 36. You have 48. Let me add this one, the 60. And then put 3 dots here. Then erase the multiples of 4. You have the 4 here. Starting with the 4. 4 plus 4. You have the 8. Plus 4, 12. Plus 4, 16. Plus 4, 20. Then 24. 28. Then you put 3 dots indicating the multiples as low end. Then you list the multiples of 6. Okay. The multiples of 6. So you start with the 6. 12. 6 plus 6 is 12. Plus 6, 18. Plus 6, 24. Plus 6, 30. Plus 6, 36. Then you put dots here, indicating that the multiples are endless. Now you find the common multiples of 3 of them here. Common multiples of 3 multiples. So the number that appears in the multiples of 12 and at the same time appears in the multiples of 4 and then in the multiples of 6 at the same time. So you realize that we have the 12 in the multiples of 12 is 7, 12 in the 4, and 12 in the multiples of 6. Then we also have 24. 24 also the multiples of that. And then you put 3 dots, indicating that we will still have common multiples, okay? And then you list the least common multiples, which is the LCM, okay? The lowest in the common multiples, and that one too is 12, okay? Great. So this is how to find the LCM of 3 given numbers. You list the multiples of all the numbers, and then you list the common multiples, the number that appears in all the 3 numbers, all the 3 multiples that you have listed, and then you select the least in the common multiples. Let's use the prime factorization method to solve this one. Now you have the 12 here, the 4, and then the 6. You underline the mix. Okay. We are to reduce the numbers to 1. Okay. So since they are all even numbers, don't waste time to choose 2. Okay. So we choose 2 here. So the 2 can cancel all the 3 numbers at the same time. Okay. Good. So 2 cancel 12 6 times. Good. The same 2 cancel 4 2 times. The same 2 cancel 6 3 times. Good. Now the numbers, the 12 has reduced to 6. 4 has also reduced to 4, reduced to 2, and then the 6 has reduced to 3. Then you think about it, number that can cancel the 6, 2, and 3. If not possible, then you think about the number that can cancel the first 2 numbers or the last 2 numbers. Okay, I think the first 2 numbers are even numbers, so you can still use 2 to cancel. Okay, good. 2 cancel. 2 cancel 6 3 times. Okay. Then The 2 cancel 2. 1 time here. 2 cannot cancel 3. So you have to repeat the 3, okay? Because 2 cannot cancel the 3, you have to repeat the 3. And once we have getting 1 here, it means you have done with the 2. Once you get 1, it means you have done with that particular number. You will not come back and cancel. You don't cancel 1, okay? So now the numbers left are 3 and 3 here. Then you choose a number to cancel them. So you have the 3 and 3. Now a number to cancel them is 3. Okay. 3 cancel 3. 1 times here. And then 3 cancel this 3. That is 1. So you are done with these 2 numbers again. So the main motive for using this prime factorization method is to reduce the numbers to 1. Okay. Therefore, the LCD is the numbers that help us to reduce these numbers here. So that is the 2 times 2 times 3. Okay. 2 times 2 is 4. 4 times 3 is 12. So here is 12. Okay. Good. Now with the 5 and 3 here, when you're using the multiples method, you find the multiples of 5, and then you find the multiples of 3. And then you find the common multiple that appears, and then you list the least one in the common multiples. Let me use the prime factorization to solve this one. The 5 and 3 then you choose a number to cancel the 2 numbers at the same time. If not possible, because here is 5, here is 3. There's no way you can get the 2 numbers to cancel these 2 here simultaneously. So if you reach to this point, use the number themselves. So the number here is 5. So the first one is 5. Cancel a7 to get 1. 5 cannot cancel the 3. So you have to repeat the 3. Okay. Good. Now, left one number here. Therefore, use the 3 a7 to cancel this 1 to get 1. Now, once you get 1, it means you have done. So therefore, the LCD is equal to 5 times 3. Okay. And that one is 15. Okay. That is 15. So when you list the multiples of 5, the multiples of 3, the common multiples, and the lowest in the common multiple, you still get 15. Okay. Let's proceed. Good. Now change the following improper fraction to mixed fractions here. Now we have the improper fraction to mixed fractions. Okay. Good. You write your solution. And we said the mixed fractions, they are fractions with a whole number. So when you take 7 over 2, you divide the 7. So here, the 2 goes into 7. 2 goes into 7 here. How many times? Saying 3, okay? Or 2 times sin A closer to 7. Okay, 2 times 3 is 6. 6 is closer to 7, okay? So 2 times 3 is closer to 7. Now, therefore, we have the 3 here to be our whole number, okay? That is our whole number here. And we said the denominator of improper fraction is the same denominator for what? Mixed fraction. So the denominator here is 2. So here 2 is 2. The remaining one up to 7 must be the numerator. Okay. So once you get the 2 times 3 is 6. When you subtract the 6 from the 7, you get 1 as a remaining to in order to fulfill this 7. So that one will be what? Or 2 times 3 here will give you 6 plus what will be equal to the numerator here, plus 1, okay? So you have the 3 whole number 1 over 2. When you take 21 over 5, you do your divisions here. The 21, which is the numerator, will be in the box. The 5 will be outside. 5 times sin A closer to 21. 5 times 4 will give you 20. Okay? 5 times 4 will give you 20, which means that our whole number here is 4. Okay? Good. The denominator of improper fraction is the same denominator for mixed fraction. Now we have our 5 here. Okay? Then 5 times 4 is 20, plus what number that will be equal to the numerator of the improper fraction? Plus 1. So here is 4 whole number 1 over 5. 5 for 20 plus 1, that will give you 21 over 5. When you get the 19 over 8, okay, good. Then the 19 will be in the box, and the 8 here will be here. 8 times sin A closer to 19. 8 2 will give you what? 16. So 8 2 will give you 16. So the 2 here is closer to 19. 8 times 2 is 16. 16 is closer to 9 because 8 3 will be more than 19. So you choose the one that is approximate to 19. Now you have gotten our whole number to be 2. This is how to get your whole number. Then the denominator for improper fraction is the same denominator for mixed fraction. Okay, so here is 8, here must be 8. Now, in order to get the numerator for mixed fraction here, multiply the 8 by the 2, that will be 16. 16 plus what number? That will be the numerator will be equal to the numerator of the improper fraction. So 16 plus what number? That will be equal to 19. 16 plus 3 will be equal to 19. Okay, so here is 2 whole number 3 over 8 is what? This fraction for 19 over 8. Good. If you want to change the mixed fractions to improper fraction, now we have 3 whole number here, 1 over 2. Okay, we want to change this one into improper fraction. We always multiply the numerator here, which is the 2, by the whole number here, okay? And then we add the result to the numerator of the mixed fraction. The denominator of mixed fraction is the same denominator for improper fraction. Then here you get 6 plus 1 all over 2. And the final answer here will be 7 over 2, okay? So this one will be in the bracket, okay? Now when you take 4 whole number 1 over 5, we always multiply the numerator by the whole number. So the denominator by the whole number right there. So the denominator here is what? The 5 times the whole number, which is the 4. Then you add the results to the numerator. The numerator is 1. Then all over the denominator for improper fraction is the same denominator for mixed fraction. So here is 5. When you solve this one here will be 20. You multiply those 1, 20 plus 1, all over 5. You put them in a bracket, okay? And the answer here will be 21 over 5, okay? When you have the 2 whole number here, 3 over 8. If you want to change this one into improper fraction. Improper fractions are fractions in which the numerator is bigger than the denominator. Now, you multiply the denominator of the mixed fraction by the whole number of the mixed fraction. So the denominator is 8, multiplied by the whole number, which is the 2. Put them in a bracket here. Then you add the numerator of the mixed fraction, which is the 3, all over the same denominator. The same denominator is what? 8, okay? Then when you perform the action, 2 times 8 or 8 times 2 is 16 plus 3. Put them in a bracket, all over 8, okay? Good. And here will be 16 plus 3 will be what? 19 over what? 8. Good. Good. So that is the vice versa. Let's solve this one and then end our lesson. Whenever you have a mixed fraction and there's a subtraction, make note, never subtract what the whole numbers. The first thing is that you change all the mixed fraction to improper fraction, okay? You change to improper fractions. So 8 times 8 plus 1 will be what? 8 times 8 is 64 plus 1, that will be 65. So here is 65. Here is 65 over 8, okay? Minus 4 times 5 is 20, that plus 3, 23. 23 over 4, okay? Then When you get to this stage, you have to change unlike fraction to like fraction because the denominators are not the same. So you change them to, then you find the LCM. So you find the LCM or the LCD of what? Of 8 and 4. So we have your 8 here, good, and 4. I'm using the prime factorization method because they are all even numbers. I will start with the 2. 2 goes into 8 4 times. The same 2 goes into 4 2 times. Then I will start again. Now they are all even number again. So I will use 2. 2 goes into this 4 2 times. 2 goes into this 2, 1. And then we are done with this one. So left with the last one, which is the 2. So 2 goes into this 2, 2. No. 2 goes into 2, that is 1, which means we are done. So therefore the LCD, which is the same as the LCM, is 2 times 2 times 2, okay? 2 times 2 is 4, 4 times 2 is what? 8, okay? Now you are getting our 8 to be the LCD or the LCM. The meaning of the 8 here means what? It means the new denominator, or we should rename the fractions and make sure that the denominators will be 8 8. So when you take this one, then you come to this side, you write the rename or renaming. So you take the fractions one after the other. So the first one is what? Which is 65 over 8. You want the denominator to be 8. So which means that the new fractions here, the 8 to 8. The 8 was multiplied by 1 to get this 8. The same one must use to multiply the numerator. And here will be 65, okay? So when you rename 65 over 8 and you want the denominator to be 8, you'll still get the 65 over 8. Then you take the other fraction, which is 23 over 4. You leave a space. You want the denominator to be 8, okay? So the 4 times what gave us this 8? 4 times 2 gave us this 8. Therefore, the same 2 must use to multiply the numerator. So here will be what? 46. Okay. Good. 46 over 8. Now we are getting like fraction. Therefore, 65 over 8 minus 46 over 8. Since the denominators are the same, then you choose 1, okay? And then you subtract only the numerator. So 65 minus 46 all over 8. When you subtract this one, you get 19, okay? Get 19 over 8. Since 19 over 8 is improper, so 19 over 8 is improper fraction, you need to change this one to mixed fraction, okay? So 8 goes into 19 how many times? 2. Now we have the 2 whole number here. The denominator still remain 8 because the denominator of mixed fraction must be the same denominator of improper fraction. Therefore, 8 times 2 will give you what? 16. 16 plus what number? That would be exactly 19 plus 3. Okay, so therefore, the final answer is 2 whole number 3 over 8. Okay, so always when you are dealing with a subtraction, never subtract the whole numbers. But when you are dealing with the addition, you can add the whole numbers separate, and then you solve the fractions and bring back the whole number again. But when you are dealing with the subtraction, make sure you never subtract the whole numbers, because we make an attempt now, yeah, and if you be a bit till last hour before you'll be able to get the final answer. So change everything to improper, and then you find the LCD, you rename the fractions, and then you deal with the numerators by choosing one of the denominator. Okay, thank you.